is not so simple actually, but there are a lot of mathematics again involved, which I don't want to go into, but this is the basic idea. What is the third task? Third task is actually implement. That means I have inputted the name here, I have inputted the age, and I have inputted the loan decision. I have inputted the income. Based upon these rules, I want to find out whether it is risky or whether it is safe. So 3 steps. First task is training. Second task is testing whether it is giving us the correct rules or not. And third step is what is actually called as the implementation of the rule. Okay? Right? So just note one thing, that we are inputting the name, age, income. Our target variable over here, or sometimes we call this as a level also, that is a loan decision. Loan decision means we want to find out. Target means to say we want to find out whether it is safe or whether it is risky. Again, let us go back. So this is what we were saying. Without machine learning, we need to give specific instruction. With machine learning, no need of specific instruction, just the data. So this is what I just said. The features will be input. So in the example that I had said, how many features were there? In the example, there were 3 features in the example. Target Y. What was the target in the example that I had shown? The target was the loan decision. So initially, this data is input. This is called the training data, which I am highlighting. This is the training data. So this will be given to the learner or the algorithm. So that will create the model. What is the model? The model is the set of rules that I have shown. Okay. After that, it needs to be tested, which of course it is not being shown here. So if it is sufficiently correct, then I will input those 3 features and I will get a predicted value of Y. That is whether the loan is safe or whether the loan is risky. Okay. So a black box model is a system that does not reveal its internal mechanism. Sometimes we say that the system is like a black box. What is a black box? Black box means to a system we are giving certain input. So the model is something, it is giving us the result. So it is not telling us that why we have the result. It is just telling us that such and such is the result. Isn't it so? Right? Achha. For example, if I give an example, for example, the exams that we used to appear earlier, isn't it? Whenever we used to appear in some competitive exams earlier, maybe 20 years to 25 years ago, right? We used to appear in the exam and we were told whether we were selected or whether we were not selected. Rather, if someone was not selected, he was not told also. A list of selected candidates were published. So this is like a black box. Nowadays what happens? So person is appearing in the exam and a mark sheet is being published, right? That such and such has secured such and such marks in such and such subject, and based upon that, in which subject the person has failed to qualify and so on. Alright? And then perhaps the rank of the person, like we have in the various competitive exams, and it's so. So in machine learning, black box describes models that cannot be understood by looking at their parameter. Okay, so basically we are giving the parameters as input. What are the parameters? Parameters means the features that I have just shown. In the example that I had shown, that there are 3 features. Okay, so those were the parameters, right? So what is the black box? The black box could be a neural network and automatically it is giving us the answer. So the opposite of black box is sometimes referred to as the white box. Okay, the opposite of black box is sometimes referred to as a white box. Okay, what is white box? Just the opposite. That means we are giving some input and we are given certain answer. Why that answer is selected, it is telling us, right? So this type of model is something that is being called as the interpretable model. Okay, it is called the interpretable model. That means it is giving us an interpretation that why such a model has been chosen. As an example, let us say a student has given an exam, or a student is to appear in an exam, right? And a certain machine learning algorithm based upon his previous results says that he should get 42 for the exam. Now, obviously, the student is free to ask, why do you think I will get 42? What is the logic behind the prediction that I will get 42 for the answer? So, if it is just AI, there will be an awkward silence. But if there is an XAI, then of course, why the person is getting 42, there should be a satisfactory reply. So, interpretable machine learning refers to models that makes the predictions of human machine learning systems understandable to humans. Okay, right? Models, machine learning systems understandable to humans, right? Understandable to humans. That means I am making some interpretation. Okay, I am making some prediction rather. I am making some prediction. So why I am making the prediction, that we should be able to understand. Alright? That we should be able to understand. Okay, alright? So, what actually, on what basis they are done? They are done on the basis of the features. For example, in the example that I have shown, there were 3 features, and then of course, the fourth, that means whether we want to provide a loan to the person. Okay, loan status, which we had said. Okay, so that is the target. The first 3 variables are the features based on which we are taking the decision. So actual value of the decision, actual decision is the target, and the value of the target is what is called as the prediction, right? That means whether that loan will be given to the person or not. Okay, alright? So prediction is what the machine learning model guesses the target value should be. Again, if we take this example, just a recap, name, age and income, these are the features. This loan decision is the actual target, or this is called the level. So it has 2 types of values. One is safe, another is called the risky. Okay, right? So in that case, we will say that prediction is safe or risky, and the target is what is called as a loan decision. Okay, now we are coming to the concept of interpretability. So what is interpretability? So interpretability is the degree to which a human can understand, the cause for a decision. That means the system is making a decision. Okay, so in a black box, what did we say? We say that the decision is only given to us. Why the decision is given, that is not clear. So over here, in interpretability, the cause is required. So higher the interpretability of the machine learning model, it is easier to understand why a certain prediction has been made. That means why the prediction is being made. So it should be able to understand why we are making that prediction. Okay, so the term interpretable and explainable may be used interchangeably. So we may use the term interpretable, or we may use the term explainable. Okay, anything. Okay, both are the same exactly. Now the question, this is the main thing actually. So if the machine learning model performs well, why do we just why do we not just trust the model and ignore why it make a decision, why it make a certain decision? Okay, that means we know that the model will always give the correct result. Maybe we assume that model will make the correct result, give us the correct result. So if we know that the model will make a correct result, then what is the need of explanation? Isn't it so? For example, in cricket, earlier we had the umpire, isn't it? So that umpire used to make some wrong decisions. So for that, recently, DRS has been introduced, isn't it? So DRS, it makes the decision. After making the decision, it shows to us that why it has made the decision, isn't it? So no need of showing, it could have given us that it is out or not out, isn't it so? But then again, the problem is that the single metric such as classification accuracy is an incomplete description. That means we have seen that the DRS, it is all the time not able to make the correct decision, isn't it? Sometimes it has made some decisions which of course it is not correct, isn't it? So question is not what, but why. That means why has such a decision been made? So importance of interpretability. Okay, why is interpretability actually required? So first one is that human curiosity and learning. Okay, so whenever we see something, whenever we see someone has made some decision, so we try to make a mental model of that why such a decision has been made. For example, let us suppose a person has fallen sick or a person is having fever. Question is, why has he fallen fever? Why is he having fever? Isn't it? So it could be due to cough and cold, or it could be viral fever, or it could be due to respiratory tract infection. Okay, right? It could be several reasons, isn't it? There could be several reasons why a person has a fever, right? So that reason has to be found out, right? That is why we go to the doctor whenever we are unwell. We go to the doctor and try to find out the reason. Next is find meaning in the world, right? Find meaning in the world means harmonize contradictions or inconsistencies. Sometimes there are some events that are occurring which we are not able to understand why they are occurring, isn't it so? Right? For example, we all love our pet dogs, but sometimes the pet dog has bitten us. So why is it so actually? We may be wondering, isn't it? So that could be a case. So this is an example. You will find out an example of XAI is this product recommender. Product recommender means, let us suppose you want to buy something. Let us suppose you want to buy something from Amazon. So if you want to buy something from Amazon, along with that product, it will show you two other products, isn't it? For example, I have taken the example, a person wanted to paint the house. So he ordered for certain colors. So these are the colors it has been shown. Okay. So along with this, what are the things that are included here? First thing is that there is certain sandpaper for coloring the house. Sandpaper is required. This paint brush is required. So along with colors, these sandpapers and paintbrush are being recommended. Okay, these type of systems are something called recommender systems. Okay. Achha. Other examples of why explainable AI could be required is this. So there could be certain safety measures. For example, right, we have heard of something called driverless cars, isn't it? We have something that is called driverless cars. So what is the target? What is the target of the driverless cars? What is the purpose of driverless cars? So the driverless cars, right, a person, whenever we drive a car, right, let us suppose a bicycle suddenly comes in front of us. So what we should do? We should be able to apply the brake immediately, isn't it? So a driverless car exactly similarly should be able to understand that there is a bicycle in front, or another example could be that the automated metro, there is a talk of that there will be a driverless metro in a few years, isn't it so? Right? So the software should be able to understand where there is a station, isn't it, and reduce the speed of the train and all these things. Another thing, another point is this detecting biases. What are the various type of biases that are there? So it should be able to add discrimination and racism, that is called the bias. The process of integrating machines and algorithms. Social acceptance is also very important, isn't it so? Whenever we have these tools like Amazon Alexa, so we can use it for performing certain household robot work, isn't it? Not only Amazon Alexa, there are some robots that can perform helping domestic work also. Now, question is how they are helping or why they are able to help us, that we should be able to understand for us to accept them, isn't it? Once we understand how they are helping or what is the logic behind their work, then only we will accept them. So these are some of the places where we can use XAI. Okay. Okay. So now, what are some of the desirable features? What are some of the desirable features? So as I said, right, desirable features is that, so the machine learning model should be able to explain the decision, why the decision has been taken, right? So it has to be ensured that the decisions are fair and unbiased. That means a person has got a job. That means why has he got a job? Right, has he got it fairly, and so on. Sensitive information is to be protected, isn't it so? That means when the system is taking some decision based upon certain parameters, that parameters, the value of the parameters or the tables that we have shown, that should not be leaked to the outside world, right? The causal relations should be picked up. Only causal relations. What is a causal relation? Causal relation means, right, when something occurs due to a certain cause. As an example, I have written x equal to 1, y equal to 2. So what is the cause behind that? The cause behind that is the relationship y equal to 2x. Isn't it? Right? So this cause should be picked up very clearly. Why is there such a relationship? And easier, right, whenever we know that someone has made a decision, right, if we understand the reason behind the decision, then of course we accept it in a much easier manner. Where do we need, in which case do we need no interpretability? Where the model has no significant impact. And a very good example is that, right, we Bengalis, or we the people from West Bengal, we are very fond of traveling, isn't it? So what we do, we often see the various websites, various Facebook posts of our persons, and maybe we try to understand where is the favorite destination of this person, isn't it? Whether it is North Bengal or whether it is some seaside place or whatever, isn't it? So if this is something like a pastime, isn't it so? Right? So in this case, there is no significant impact. Second thing is that the problem is well studied. So over the years, the problem has been studied. So that is the thing. For example, optical character recognition. Okay, this is another example. The characters are being studied properly, like the characters A, B, C, D. Okay, the OCR is able to identify the characters, right? And then manipulation of the system is a possibility. Okay, For example, the credit rating. So the credit rating, whenever a person is given a credit rating, right? Whenever a person is getting a credit rating, why is he given such a credit rating? That has to be understood. So next is the final destination. If we can say this is our final destination, where we want to move to. Well, what exactly is the applicability in education? So AI systems used in LMS. What is LMS? Learning Management System. Learning Management System means the student will be able to understand the various forms of, will be able to learn from the website or the app. He should be able to upload his assignments. If we have such a website or an app, then that is called a learning management system. So learning management system and EDM tools to support learning and assessment. Okay, right? So AI over the years has been using these. So what are the major facets to this? First is called personalization. Personalization means an app may be developed for a certain student, right? Right, based upon the needs of students, right? Certain app may be developed, that is called personalization. Then there could be the engagement. So what is this engagement? So engagement means whether the student is able to effectively engage with the app, whether the app is able to help the student. Accessibility. Accessibility means whether the student is getting the help all the time, that is called accessibility. Next we have feedback. Feedback means student is giving an exam, right? Student is giving an exam. In that case, what is the feedback of the exam? How has he performed? What are the areas in which he needs to improve? That is called the feedback. Then we have something called adaptive learning. Adaptive learning, what does it mean, adaptive learning? So adaptive learning means to say that the software is such that it should be able to adapt to the changes of the learner. That is called adaptive learning. So these were all available in AI earlier. But the problem is that they were all in the form of a black box. Black box means basically they were complex mathematical algorithms working in the background of this AI system. Right? So again the term, please note, complex mathematical algorithms. Right? So these are all mathematical algorithms which no one could understand. Only a few people, right, who have developed them, or some of the researchers could only understand. Okay, so what are the pitfalls of these? So as we said, lack of transparency. Lack of transparency means, again, same thing, someone has made a decision. So how the decision has been arrived at, what are the reasons behind the decision, that has to be understood, right? So that is called transparency. Some decision has been made. So on what basis has the decision been made? Or maybe some prediction has been done. Let us say it has been predicted that in a class of 50 students, maybe 10 students will fail in the exam. So on what basis has this prediction been made? That has to be understood. So potential for bias. So if we cannot understand what is the reason why a decision has been made, so it could be, people could think that the decision is a biased decision, right? Right? It could be related to demographics, or it could be related to gender, or it could be related to race, or anything. Limited interpretability. So educators, we as educators, we should be able to understand why a certain student, he may be struggling, or why a certain student whom we find that he is not very bright, why is he excelling in the class? So dependence on data quality. Dependence on data quality means we have a very common term in computer science that is called GIGO. What is this GIGO? So GIGO means garbage input equals garbage output. That means if the input data is garbage, obviously the output data will also be garbage. So we need to understand, we need to make sure that the input data is correct, right? And hence we need to explain the reasons for the a certain answer or certain prediction. So difficulty in adapting to certain changing circumstance, we as educators, we note, right? So earlier we were under the CBCS, isn't it so? So in CBCS the syllabus was in one form, students used to study in one form. Now we have NEP. So now the situation is a little different, right? So whether the student has been able to adapt to the new environment, right, and so on, or maybe the student is currently studying in West Bengal, maybe his parents have been transferred to, let us say, Tamil Nadu, whether he will be able to adapt to the situations in Tamil Nadu and so on. So what are the approaches of AI? So there are two approaches actually. One is called the local approach, another is called the global approach. So global approach means it is based on the overall functioning. So overall functioning means to say that the overall performance, maybe I want to evaluate the overall performance of students in the classroom, whether all the students are able to do well or whether some of the students are able to do very poorly and so on. Okay. Then we have something called the local methods. So local methods focus on specific decisions, right? Specific decision means, global means it is related to the whole classroom. So local means, let us say why a particular student is not doing well. That is called the local decision, local method. For example, why a particular student was recommended for a specific learning resource. What do I mean by a learning resource? Learning resource means it could be certain text, or it could be certain audio, right? Or it could be a certain link from a YouTube channel. Anything could be a learning resource. So over here, again, we can distinguish it into two forms. One is model specific, one is model agnostic. What is model specific? So model specific means make use of inherently interpretable models, right? Interpretable model means, what are some of the examples of interpretable model? So interpretable means linear regression may be used. I have given an example of regression earlier. That means, let us say the values of x are 1, 2, 3, 4 and the values of corresponding values of y are 2, 4, 6, 8. So what is the relation? The relation is y equal to 2x. Okay. So the relationship is basically y equal to 2x. Let us say this is the relationship. Okay, y equal to 2x. This is the relationship. Okay. So this is an example of linear regression. Then we have something called logistic regression. So logistic regression is an advancement of linear regression. Then of course there are other algorithms like decision tree. Then we have decision rules and so on. So model agnostic methods can be applied to any machine learning algorithm, right? What are some of the examples? So partial dependence plot. Partial dependence plot means, let us say there are 4 features. So how these 4 features are related to each other. Okay, how these 4 features, they are related to each other. Okay, that is called partial dependence plot. Or feature importance. Feature importance may be, let us say, there are 10 features. Out of 10 features, which is the most important one? So some of the XAI design principles, so this should be based upon the user experience. That means the user who is using it, right? So he or she should be able to uh, create a system which others should be able to understand. Okay, right? Human-centered AI design, right? So it is a process that considers the needs and limitations of the end user. Okay, what are the needs of the end user? What are the limitations of the end user? And so on. Providing actionable insights by using big data analytics, right? Big data. What is an example of big data? A lot of people have often asked me an example of a big data. So I'll give you a simple example. We all travel by metro part every day. So most of us use the metro, right? So per day, on average, how many people use the metro? I think it is close to 5 lakhs per day. Okay, I think so, right? 5 lakhs per day. Let us say, let us assume a conservative estimate that average it is 5 lakhs per day. So if it is 5 lakhs per day, right? That means in 365 days, what will be the amount of data? So 5 lakh records all the data of our smart card, okay, or the token, okay, right? All of them are being stored in certain centralized location, right? So if 5 lakh records are being stored per day and it is 365 days, so total amount of data will be how much? 365 into 5 lakhs. Now from this data, if we are given to find out between which two stations most people travel, so then in a year, let us say, then what? How much data we have to analyze? So it will be 365 into 5 lakhs. So this is an example of big data. Personalized feedback, that means why a student has been not able to do well in an exam is an example of a personalized feedback. So there are certain concerns that we must remember. In conclusion, we can say that there are certain concerns that we must remember. The risk associated with using machine learning decision making. So obviously, there are certain risks that are there, isn't it? So we are taking certain decisions based upon certain algorithms, isn't it so? So the algorithm is giving us certain rules. Based upon the rule, we are making a decision. Okay, so how correct the rules are, we do not know. Okay, the rules may be 70% correct. So if the rules are 70% correct, then there is a high probability